All right, Algebra 2. We are in the last section today. Okay, Chapter 11, Section 6, Binomial Distribution. This section has a little bit of both worlds here. What I mean by that is it still has probability, because that's basically been the whole chapter, but this also brings in a big chunk of algebra with this binomial theorem. And that is right here. We're using Pascal's triangle. There is a pattern that is created depending on the exponent that is given that goes with the binomial. Okay, so all of that being said, is if we zoom in here, you can get a little bit of a clearer picture. And yeah, this probably still looks like very muddy water, but what I'm getting at is that you are seeing that this triangle right here, Pascal's triangle, it's going to create a pattern based upon this exponent that goes with this binomial, okay? And the bigger the exponent, the bigger it expands itself out, and there's a lot of simplifying, and then after you simplify it, you have to condense it back down, and then you'll be done. All right, but there's a lot of little intricate steps. Okay, so here's this note right here. Yeah, last section, lots of little steps. You really need to show your work. Okay, so for some of you, you don't show a lot of work, and that affects your homework score. All right, so if we are looking at homeworks with minimal to no work at all, even if you say it's on another piece of paper, that's great. Give me that piece of paper, okay? So you must show all your work, all the steps that you are forced to do with those problems right there, okay? So you're gonna see me work one of these problems out for you in an example, and then I'm gonna save the second one for us to do together in class. And you're gonna have to show me some of the knowledge that you've picked up in this note video, okay? Now the next thing that we look at is this right here, binomial probability. So now we're back into the probability part of the chapter, and these also can expand out quite large, but I'm going to show you one that's a lot smaller, so we'll get a little intro to it. So these are binomial probabilities, where again we're using two separate parts. There's the binomial, usually something saying this is the odds of you getting what you want compared to the odds of you not getting what you want. And then you have to figure out all the little pieces of probability in between, because then they may ask you a question of what are the odds of only 3 people getting what they want, but there were 10 people or something like that. Okay, so you're going to see me work out one problem with that, and then we're going to work a second one out together as a class in class, all right, after you guys have already watched this note video. So we're going to see who's really paying attention. We're going to see who's not paying a lot of attention. And you know what? Why don't I just throw the extra credit at you right now? We'll see for those of you, because I normally put them at the end. All right, let's do a sports one here. All right, I want you guys to look something up. NBA. All right, we got a lot of basketball players in this class. Let's see what we get. Who won the NBA championship in 1982, the year I was born? All right, so there's your extra credit question. Okay, so this has to be copied down right here. This is all for the probability part. This, again, goes a little bit with the probability, okay? And now let's show you that whole binomial expanded out, where you have to use Pascal's triangle. So here is the binomial, just x plus y. There's your exponent right there, an exponent of 4. And it's important to see this plus sign. If this is a plus sign, then everything in the expanded binomial will be plus signs. But if this were to be a minus sign, because both of these examples right here do not show a minus sign, if this were a minus sign, then it would be a pattern of positive, negative, positive, negative. Okay, where this would be positive, this would be negative, this would be positive, and this would be negative. That's important to write down. Okay, you have to understand that this sign right here will affect all of the signs that you get when you expand it out. Okay, then you look at that exponent, and that is the first number you put here, and then 0 is what you put next to it. And you're doing combinations all the way through until you get to the last number being the same as the first number. All right, so you start with 4, 0, then 4, 1, 4, 2, 4, 3, and then you get to 4, 4, which means if you had a 5 as your exponent, you would end it when you had a combination of 5, 5. Okay, and another nice thing is that 4, 0 makes 1. 4, 4 makes 1. So your first and last combinations will always have a coefficient, this number up front, as a 1. The inner coefficients, meaning these quantities that are sandwiched inside the binomial being expanded out, these ones are going to be different, okay? And Pascal's triangle is helpful here, but if you don't want to memorize or write out all of Pascal's triangle, then you will simply want to calculate using your calculator under the probability part. When you push math, then go over to probability, and then punch in this info right here, 4 combo 1, and then you'll just keep working that out. Then what you pay attention to is the first term right here gets the full exponent. The second term right here gets a 0. So this is also following a slight pattern where if you start with 4, 0, right here, you start with 4, 0. But this is where it separates itself. Each of these, this one goes down by 1, this second one goes up by 1. So first term now goes down to a 3, second term goes up to a 1. And what you will be doing is one goes down, the other goes up, until you get to the first being a 0 and the second one being whatever that first one started with. So if we started with a 4 on the first term right here, we're going to end with a 4 with our second term. Meaning if you start with a 0 on the second, you're going to finish with a 0 on the first. And then you got to expand it out, simplify it, and then condense it all back down. So you can see all of the quantity of work that is required. Everything there needs to be in your homework. All right. So there's another problem worked out for you right there. What if you have a coefficient at the beginning? It doesn't change your steps at all, but what it does require you to do is use parentheses, because everything in those parentheses is brought to a power. And that's really important, because if you only bring this power to the variable but not the coefficient, you will be very, very wrong in your answer. So if you have a coefficient in the binomial, that will need to be in parentheses throughout the whole expression. And when you put something in parentheses, that means that that exponent goes to both parts inside the parentheses. So you're going to be expanding it out, simplifying, and then condensing it down to your final answer. Again, this is all the work you need to show here. Okay, so let's do one of these together. So this is our first one. All right, so we're starting with one where we do not have any coefficients, but the one we're going to do in class together, this one does have a coefficient right here. So we're going to do this one in class together, and that one is going to be like this example here. All right, if you want to go ahead and try this, I'm sure not many of you want to, but if you want to go ahead and try it and then check your work in class, then you can really tell if you're understanding it. All right, so back to it. Here we go. First example, we're going to expand it out and then start to simplify, and get it down to its final piece here. All right, we are working to the 5th power, and notice we have a subtraction. So with subtraction, that means we're going to be going positive, negative, and so forth. Okay, so that's the order of our signs that we have in there. So let's start with the first one. We're going to have a 5 combo 0. First term brought to the full 5th power. Second term to the 0 power. Okay. And when I say, by the way, when I say positive, negative, I'm talking about the whole expression. So notice this first expression is positive. So then we covered the positive. Now we're going to do the negative. So this is us covering the negative side. So now we have 5 combo 1. First expression drops to a 4. Second expression goes up to a 1. So we had a 5, we dropped it to a 4. We had a 0, we upped it to a 1. All right, the next expression becomes a positive. We now have a 5 combo 2. X drops down to a 3. Y goes up to a 2. Now we're at our negative. 5 combo 3. X drops down to a 2. Y goes up to a 3. Now a positive. We have a 5 combo 4. X drops to a 1. Y goes to a 4. Almost done. Then we have a negative 5 combo 5. We know we're done because the first combination now, both numbers are the same. All right, we have a 5 combo 5. We know this is going to be the last piece to this expanded binomial. And then we should have an x to the 0 and a y to the 5. So what you should now notice, we had a 5 and a 0. We've completed it. Both are 5s. We had a 5 up front. Now we have a 0. We had a 0. Now we have a 5. All of that means that we've expanded it to its full degree. Now we have to start simplifying. Okay, so let's do another color underneath it. We'll get what we're simplifying. Okay, remember that this first 5 combo 0, and when we get back here, a 5 combo 5, both of those are going to be 1. So this is a 1 x to the 5th. Don't forget that anything to the 0 power. So this y to the 0 power right here is just 1. So we don't need to write that. Now put a minus sign. 5 combo 1 is 5. And then you have x to the 4 y. Plus, and then 5 combo 2 is 10. And then x to the 3rd y squared. Remember, x and y, there's no coefficient, so there's no other number that we need to expand using that exponent. Okay? All right, then we put minus. We got a 5 combo 3. That is also 10. X squared y to the 3rd. Put a plus sign. Now a 5 combo 4. That is 5. X y to the 4th. Minus, and then remember 5 combo 5 is just 1. And then your x to the 0 power, that's a 1. So then I just need to bring down the y to the 5th power. Also, one thing to point out, if you guys don't want to put this 1, you don't have to put that 1. You also don't have to put that 1. I just wanted to show you every coefficient being written out so you could see that this truly does work to Pascal's triangle of 1, 5, 10, 10, 5, 1. It's a perfect symmetrical shape, okay, where you're going to start and finish at the same. And then it's this up to the same point, Sorry, up to the same point, down to the same point. Okay. All right. So this is as far as we can expand and simplify this down. Okay. So this is our solution right there. All right. Now the next one we're going to do in class. That's parentheses a plus 2b plus sign, and it's all brought to the third power. So it's not too bad that it's to the third power, but this coefficient 2 will play a factor in that. Okay, so let's do number 3 together. This is a probability one. We're going to do number 4 in class together. So I really want to make sure that you can track with me on number 4. This one's got quite a few steps. If you want to try it, I think that'd be great. Give it a shot. See how far you can get. Check your work as I work with you in class on number 4. Okay, so we'll do this one together. Let's do number 3, though, right now. Okay, so we are working with a probability. All right, so students are assigned randomly. Okay, that's kind of important to know. Students are assigned randomly, meaning that order doesn't matter, right? Randomly. You have one of 3 guidance counselors. Okay, so 3 different guidance counselors. What's the probability that Counselor Jenkins will get 2 of the next 3 students assigned? So all we're talking about is a total of 3 students, and there's 3 different guidance counselors. One of them is Counselor Jenkins. The other 2, of course, are not. So step 1 here is we need to figure out what is the probability that you can get Counselor Jenkins. That's what you want. Okay? So if we have 3 guidance counselors, this is going back to section 1 here, real simple. We have 3 guidance counselors. How many guidance counselors do you want? Well, there's only one that is Counselor Jenkins. So there's a 1/3, meaning that is a 0.3 repeating, that you will get Jenkins. So you have a 1/3 chance that you will get Counselor Jenkins. Well, that means the exact opposite, or the rest of it, okay, meaning a 2/3, which is equaling to 0.6 repeating. That is not getting Jenkins. Okay, so we need to start with that, simply that. And what this does is this goes into right here, binomial probability. So we have binomial experiment, n trials, okay? P is the probability of success. That's what we just calculated. We just calculated P. The probability of success is 1/3. You will get Jenkins. Then Q is probability of failure. 2/3 chance is failure, meaning 2/3 you will not get Jenkins. Okay? Then you have N trials, which means technically we're going to go back and look at the phrasing here. There's a total of 3 students, right? They're saying of the next 3 students. Yeah, right here. Of the next 3 students. Okay, so that's considered to be our trials. That's going to be N, and then 2 of the next 3 students. So that's going to be the R. That's the success. Okay, so we want 2, that's success R, of the next 3, that's total N trials. Okay, so now we're going to fill all this information in, and remember it's always going to be a combination. It's random, order didn't matter here. Okay, all right, so let's use that equation. If you don't have it, write that down, take a look at it. We're going to have a combination. We have 3 trials. 2 of the next 3 students we want to see if they can get Counselor Jenkins. So that's how we get the 3 combo 2. There's 3 total students that we're looking at. We want to see if 2 of those 3 can get it. Then we look at success. Success is a 1/3 chance, and it's brought to R, which is 2. And where am I getting this from? Again, I'm just getting this right here. This is the equation. Okay, there's 3 combo 2. 2 was the R, 3 is N. So probability of what we want, 1/3, R was 2. Then we're going to have a Q, which is a 2/3 probability. And then we're going to say N minus R, which is 3 minus 2. All right, here we go. So let's fill in the last piece. 2/3 that we don't get Counselor Jenkins. And that is simply brought to the first power. I just wanted to show you the exponent there, even though to the first power doesn't change it. Okay, now let's see. A 3 combo 2 is 3. 1/3 squared is 1/9. And then 2/3 to the first power is still 2/3. All right. Multiply all this together. Simply plug this into your calculator. Recommend that you just put everything in parentheses. Just going to make your life a lot easier using parentheses in the graphing calculator there. All right, plug that in, hit enter, simplify it down, and you get a 2/9 chance of what you are looking for here. All right, that the next 2 get assigned to Counselor Jenkins. You have a 2/9 chance. All right. So that covers the 2 example problems right there. Example problem number 1, example problem number 3, and we as a class will do example problem number 2 and example problem number 4 in class. All right, guys, that covers us. So bring your questions to class, bring your notes to class, and I will see you in the next one.